use because row you will try to allocate it by using a malloc function. How many rows I want to allocate? I will be using that loop for this. Now in that case, I will be using like this for I is equal to 0, I less than number of rows you want, and I plus plus. And then you can use, now in this case, rows is equal to 5. And you will say you will write a star, str plus I is equal to capital star malloc, and for each one you want 15 bytes, therefore write 15. This will work 75 times. This will work for 5 into 15, that means you reserve 75 bytes, and this will reserve 75 bytes. Each row will say 15 bytes, like that. Okay. Now this we have done for arrays. Now once I am going to write a program, now what you have to do? I will just write a pseudo code, and you should fill those codes yourself to make a complete program. Now if you can write the program to sort, the question is like this. Write a program to sort in strings. Write a program to sort n strings. Now obviously using pointers. Let me make it like this. So you can do using an array, but I would like to use as a pointers. Now I will just write a pseudo code, and you try to fill over there. You want to fill all those codes in order to get the thing. Now I just try to show you how it will actually work, and I write a pseudo code for this. Now I write a pseudo program for this. And the pseudo program, what the meaning is that I will just write what you have to fill yourself, and I'll just give a hint at what you have to write. Now here, what you do is that you write a main, you declare a pointer to a character, to character string, then allocate memory to this. Then write a loop to read the strings. Then you set up two loops to perform now. Why I did two loops? Because sorting cannot be done in a single loop. In the first loop, you will take the number of passes, and the second loop will try to compare those things. Now, those of you might have done in the second semester, or first semester can do it. Otherwise, I'll just give you a small code that how you are going to perform a loop for sorting. Now, in that case, just I'll try to come to this place to just show you that how the sorting algorithm works. Now, how it works? Suppose how to write a sorting code. Okay. Anybody having any doubts, please ask me. Now let us take an array like this. Let us take a simple array. Suppose the number is 4, 8, 2, 1, and 6. There are 5 numbers. So let's try to apply the sorting algorithm. The easier ones I'll apply it. For example, the selection sort, the bubble sort, insertion sort, are all those are the simple functions, and I can apply those codes over here. Now here, just suppose if I take an array, it is a of 0, a of 1, a of 2, a of 3, and a of 4. Now, while sorting, how many times are required to sort? Now, obviously, if you are going to use any algorithm like selection sort, now what happens selection sort is that you are going to use like this. What I do is that I am going to first make a loop like this. Now understand this code very well, because this is the one we use in the case of sorting with the strings. What I do is that I will be taking the first element and compare with 8. Then I will compare again the top element with the third element, top with the fourth element, top with the fifth element. And if the first one is smaller than second, I will swap those. If it is not smaller, I will leave as it is. That means in the first time, if there are 5 elements, I require 4 comparisons. Now here what will happen when you compare 4 with 8, 4 is smaller, nothing to do. Then I again compare, therefore I will first make one comparison here, second here, third here, and fourth comparison. It means that if there are 5 numbers, I require 4 comparisons. Okay. Now, in the first comparison, when I compare 4 with 8, 4 is smaller, so nothing to be done. The second time, when I find that compare 4 with 2, 2 is smaller, therefore what I will do is that I will swap these values. I will swap these values. That means 2 will come here, 4 will come here. The rest of them will be like this only. Now this will be the new array. 2, 8, 4, 2, 8, 4, 1, 2. 2 and 4 are swapped. Now, in the second, I will again compare 4, 2 with 1. Again, 1 is smaller. Therefore, you swap those values, and 1 will come here, 2 will come here, 8, 4, and 6 will remain as it is. And this is the status. Now, how many? After 4 comparisons, I again compare 1 and 6. But since there is nothing to be done because 1 is smaller, and then what happens is that after first pass, I get this status 1, 8, 4, 2, 6, and it is evident that 1 has come to the correct place. Now 1 has come to the correct place. Now this is nothing but you say the first pass. First pass of algorithm. Now I did how many comparisons? 4 comparisons. How many swaps were there? 2 swaps. First, when you swap these two, once when you swap these two, when you swap here 4 with 2, the second time you swap 2 with 1. Because there have been 2 swaps. In the worst case, there could be all 4 swaps. In the best case, there will be no swaps. For example, you are having all the numbers are sorted order. Obviously, no swap will take place. If all the numbers are in descending order, you will have all swaps. Therefore, it depends on data to data. In the worst case, the first pass will have n minus 1 number of swaps. In the best case, it will have zero swaps. But you have to compare for all. Now, once I get this array, and for the second pass, I will take this array, the same array, 1, 8, 4, 2, 6. But here I will be using only these elements. I will not be using these elements. Because 1 is already sorted. I will compare 8 with 4. 8 with 2, the top with the 2, like this. So there are 3 passes. In the first time, this will become 4, 8, 2, 6. Again, in the second time, this will be becoming 2, 8, 4, 6. And the third time it will be same because there will be no swap. If you're coming 2 with 6, there will be no swap. Therefore, 2, 8, 4, 6 will be there. And one will be already copied from here. Therefore, I will copy just one over here and be copying one over here. And this is the status of the array. Therefore, in the second pass, you did 3 combinations and you got 1, 2, 8, 4, 6. Similarly, the third pass, what will happen? The third pass, you will be taking this array as an input, where the input will be 1, 2, 8, 4, and 6. These 2 elements already sorted, nothing to do. And then you compare here 8 with 4 and 8 with 6. Only 2 combinations. And then in this case, what will happen? 1, 2, these 2 will swap, will be having a swap over here. The 4, 8, and 6 will be there. And then you again compare 4 with 6. It will already be is bigger. Therefore, what you do is that you just you stop the pass, and in the fourth pass, you will have 1, 2, 4, 8, and 6. This already sorted. And you just make one comparison between these 2. Since 6 is smaller, what you do is that you swap and you get this result. 1, 2, 4, 6, and 8. And by this one, you get that this is the final result. This is the final sorted array. Now, one thing what is important, you have to just check how it is happening. For 5 elements, I require 4 passes. 1 pass, second pass, third and fourth pass. Therefore, in this case, the passes will be equal to n minus 1. And for the comparisons, it will be the first time it will be n minus 1, second time it will be n minus 2, third time it will be n minus 3, dash dash up to 1. That means in the first pass it will be n minus 1, n minus 2, n minus 3, dot 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 up to 1. That means since there are only 4 passes, first time it will have 4 comparisons, then 3 comparisons, then 2 comparisons, then 1 comparison. Now, by this concept, you have to write a loop for this. You have to write a loop in such a way that I will set up a loop for 4 number of passes, and then I will set up a loop for comparisons such that each time the inner loop will be 1 less than that. Now, this is a selection sort form. In the bubble sort, a little different, but it is having the same thing. You compare first with second with third, third with fourth, fourth with fifth. That means you are going to compare 4 with 8, then at that position what you get? 8 with 2, 2 with 1, 1 with 6, and keep on doing like this. That means you sort first and second position, second, third, third, fourth, fourth, fifth, like this. Therefore, in that case, you are going to bubble the element which is the biggest element at the bottom of the array. Therefore, that is the difference between those. The sorting complexity of selection sort and bubble sort are same. It is totally having the same thing. Therefore, it doesn't make any difference whether you are going to sort using bubble sort, because the time complexity for sorting is nothing but n square. Therefore, these are I'll show you the time complexity for this algorithm is order of n square. N is the number of elements in the array. Now, some of you might ask me that why did it become in squares? Now, just to make sure that how it works, let me tell you the comparisons. Let us find the number of comparisons. It is nothing but the first company it is n minus 1, in the second one it is n minus 2, in the third one it is n minus 3, and in the nth minus 1 comparisons it is 1. You find the sum of this, it is AP series for a 1 to n minus 1, the sum will be nothing but n into n minus 1 by 2. Now if you are going to expand this, this will become n square minus n by 2. Correct? This is simply APC, you all of you know. 1 to n minus 1. If it would have been 1 to n, it would have been n to n minus 1 by 2. Now here, if n is large, n square will be much larger than n. Therefore, compared to n square, n is not much significant. Let us take an example. Let us take say n is equal to, suppose, 1000. Now this will become nothing but 1000 square minus 1000 by 2. Now 1000 square will be nothing but 10 to the power 6. Now compared to this 10 lakhs, 1000 is nothing. It's a very small value. Because this value is 1 million. Therefore, in that case, when n is large, n is negligible in front of n square. But if both are same, n is small, for example, n is 5, then in that case 5 square 25 minus 5 is having some importance. Now, when you compare the complexity, I don't take this because these are small values. And even 10 lakhs divided by 2 is also a significant value. Therefore, if I take 10 lakhs divided by 2, again it becomes 5 lakhs. Therefore, in that case, you can neglect this also. And the overall, that means what I do is that I neglect n square, and this is the worst case complexity of this. It will become order of n square. The worst case means it won't take more than that. But that does not mean that it will always be equal to n square. It will not be equal to n square, it will be less than n square. But in the worst case, it will not be bigger than n square. So when I talk about this way, I say that this is the worst case Almakhil performance. Now in that case, if I ask you how much time you will take to travel from Jammi Milliard to Connaught Place, so some of you might say half an hour, some of you might say 45 minutes, one of you might say 1 hour, one of you might say 1.5 hours. Now, taking all that disturbance and all the factors in between, suppose if some of you say 1.5 hours, that is the worst case. If you find that there is a traffic jam at many places, there is a chance that your bike may break down, and taking everything into consideration, you take 1.5 hours. So that is nothing but the big O complexity, and we say the worst case. You might reach in 1 hour only, but your worst case is 1.5 hours. Now I will be satisfied that take all the factors into consideration, your time to reach from Jammi Milliard to Connaught Place will only be 1.5 hours. And therefore when I talk about this big O notation, when I talk about big O notation, we say big O. It means it's a worst case design. O is written as OH, just therefore I say big O. Therefore, this is the worst case design for this. Okay. Now coming back to this problem, let me set up a loop for this. Now coming with this, I want to set up a loop for this. Now how to set up a loop? I will be just coming to this. Therefore, I will just be using. I will just be showing like this. Now I will write a loop for I is equal to 0, I less than n minus 1 plus I. I will set up another loop for j is equal to 0. Okay. Now here, the value of j is such that it is going to start from the value. Therefore, in that case, I have to make sure that if the top loop runs one time, the bottom loop should work 4 times. Now, in this case, it will be like this. When I will be having a value of 0, j will should run 4 times. When I will take 1, it should run 3 times. When I will take 2, this should run 2 times. If this take 1, sorry, if it takes 3, if it takes 3, it should work 1 time. This is the time of working for this loop. Okay. Now in that case, when in the first case I is 0, j should work 4 times. Now what should I do? Anybody can give an answer. What should I put over here? Such that when the value of I is equal to 0, this should work 4 times. Anybody? Can
J
give
equal
what?
to J equal to I.
Y.
Okay. One answer is that j is equal to I. Like this. Okay. And like j is equal to I. Now, I, j less than n will run 5 times because if n is 5, j is equal to 0 to n will be 5 times. Therefore, in this case, I can write n minus 1. Now what will happen? When j is equal, when I is 0, j will become 0 to n minus 1 is 4 times. When I will become 1, n minus 1 will be 4, therefore it will be running 3 times. And so on. Because here when j when I is sorry when j is equal to 0, j less than 4 will run 4 times. When j will become 1, this it only will run 3 times. When j is equal to 2, this will be same and it will run 2 times and keep on doing like this. J is equal to 3, it will run 1 time. Therefore, this will run 4 times. This will run 3 times. And so on. This will run 2 times. This will run 1 time. Okay. Now this is how you are going to control the loop. Therefore, in that case, this is the actual loop what you have to do. Now, in that case, what you have to do is that you have to set up a loop. Now, this is a loop for selection sort. And here, what you are going to do is that you are going to write like this. And here, you write the comparison and swapping statement. Write the comparison and sorting statements. Now now taking into this, what you have to do is that I come back to the original slide, which I have used over here. Okay. Now here, for this one, you write that loop. That means set up a loop to perform sorting. You just take those things over there and set up a loop over there. Then you just, after that, what you are going to do is that you just print the sorted strings. That's all. Now this is the pseudo program. You have to fill those parts. Now, when you are comparing two strings, you have to use the function string compare, because you cannot compare is Delhi equal to Lucknow. Now, in that case, whenever you want to compare two strings, you have to do like this. Therefore, what you have to do is, if suppose this is a type of thing, if you want to compare Delhi and Mumbai, you know the position of Delhi and the position of Mumbai. You compare string compare of this. Now, once you know this, what I have to do is that if I write like this, say if I write say T is equal to string compare of, let us take it, suppose if I say str I can write like this. So try to understand this very well. Where I contains say Delhi, STRI, and I plus 1 contains Mumbai. Now what will T contain? T will contain the difference between Delhi and Mumbai. Now we told you in the last class, we will compare D with M. You know that D is smaller than M, therefore the value for this D will contain some negative value because the ASCII value of D is nothing but 66, 67, 68, 69. Therefore the ASCII value of D will be 69. No, 68. 68. And for M, it will be a 13 number. That means it will be 66, 65 plus 13 is 27. 65 plus 13 will be 78 minus 1, 77. So these are value for D, M. Now that means compare 68 with 77 and it will give you minus 9. And then when it comes to minus 9, T will contain a negative value. If T is negative, don't swap. If T is positive, you perform a swap. If T is negative, don't swap because it means that the top string is smaller than the bottom one, don't swap. But if it is smaller, you have to swap. Now let us try to see how you swap. Now I'll just write a code for swapping. In this case, I'll just show you how to swap over here. Therefore, what I do, let us try to do a swapping of strings. Now, suppose the same I will write. Here, suppose here if I have say Delhi, Mumbai, and so on. Now what I will do, if I want to swap these two, I have to take it into a temporary string. Therefore what I do is that I declare one temporary string, no character, I will say temp of say 15 because maximum I took 15. Now I will say string copy, temp, comma, that str of I. Then I will say string copy, str of I plus 1, comma, str of I. And then I say string copy, str of say I plus 1. Now what I did, I took one temporary variable temp and in this I saved Delhi. Then I compared Mumbai and Delhi position. Now what will happen if you see this code, what will happen is that this value will be copied over here. Now this value will be copied at this place. No, just I am trying, but this is not correct because Delhi is smaller. Now let us try to say maybe this is not. Let me explain it like this. Suppose this is not Delhi. Now suppose Mumbai is over here. Suppose Mumbai is at this place and Delhi is at this place. Now what I did, I saved this. I saved Mumbai. I saved Mumbai. Then I just copied Delhi over there. Therefore, what it will do, it will just copy this Delhi over this. It will copy Delhi over here, and Delhi will remain here also because you copied here. The second statement, you will be able to, if you copied over here. The third one, what you did, you compared 10, you copied 10 to 10. Therefore, now this will be copied and you will copy Mumbai over here. And you find that you have swapped Delhi and Mumbai by using a temporary variable. That means I saved Mumbai first, copied the second location to the first location, and from temporary to the second location. You know that when you are trying to swap two values, you normally require a third variable. You require a third variable which is going to save that value. Therefore, this is the whole code. And when I wrote that how to swap two values, now in this case, what you will do is that when you are going to write this code over here, therefore, when you are going to set up two lists for performance, when you are going to do this statement, whenever you are going to write this one, you have to first of all set up a loop for sorting. In the sorting, you have to first compare and then swap. And then once you are going to, all these codes are there, therefore you can print the sorted strings just like you have done a loop to read the two strings. Therefore, these you know that these two are same, except that one requires a print statement, other requires a scan statement. Okay. Now, this is the program what you can write. Try to write the program yourself, and let us see that most of you should be able to do that. Otherwise, I'll write the program and show you how to. I will upload the program on your classroom, and you can do it. You can see that if you are not able to do that, you can do it, but don't try to just check my program, because I want you to first try to practice. If you can do that, you have understood pointers. You've understood pointers. That means we say that array of pointers to strings. Also, that means this is the top one of the good program which at this level you should be able to do that. Any questions?
Excuse me, sir. Excuse me, sir. Sir, sir. Actually, sir, as I belong to a foreign student, sir, I am living right now outside from India. That's why I can't order the offline books. I mean online books. So I want, sir, PPT of the sir, your preferred books. So if you can make available of those things.
Some of the books which are there, which are available, I will sending it to that. Those are some of the free books are there. Actually, if you find some of the sites, if you have an idea of this Jamia Millia library, or if you have your ID for student ID, you can access our library from the online also. But that is from open source is there from there. Therefore, there is no need to come to Jamia. You can access that, and for that you have to request an ID at the Jamia domain. Now, most of you might not be knowing that we provide you an ID of Jamia ID. Jamia ID can be provided by giving an application to that, and that ID will contain at st.jmi.ac.in. Now, in that case, we will provide you an ID where we will be writing like this. We will be at st.jmi.ac.in. And with this ID, you can access the Jamia thing, where this one will contain your initials with your normal number. So that part will be there, and you can access that. But some of the books which I am having right now, I will be sending you to your email. Therefore, or you can do it. Otherwise, you can, if you search the net, most of the books you can get. Now, till now, I have not been using any book of data structures. But as and when the class progresses, I'll be using 2 or 3 books. One of them is Chomsky's by Simon Diffus. That's one of the book I'll be using. Therefore, that is one book. The second book which I will normally be using, that is one of the books which is available. Not in, it's an In the US edition book is there. Therefore, I will not be able to provide the e-copy. I don't know whether e-copy has come or not, but I'll be using also. I'll be following Classic Data Structure by D. Samanta. That also book I'll be following for trees. Therefore, but initially I'll be following some of the good books um, Tannenbaum, Data Structure by Tannenbaum, and there are a lot of good books which has come recently. Therefore, no problem. I will send whatever I am having over there. I have already uploaded most of the lectures, even the videos. Therefore, you are free to buy them if you feel like. Anytime you ask me. Now, I like to tell you that don't think that if I am doing the class, you can do it on your own directly. It will take time. Though you might not be very conversant with programming, and I don't expect that you can write all the program yourself. It will take some time. Therefore, gradually it has to be developed. If you are not done programming before, I don't expect all of you to write this program. Because this program is not that simple. There is lost lot of concepts. Therefore, I told you, you write a small program to first perform the string copy. Write a small program to do string length. Write a program to string compare. So if you keep on writing all those programs, you can combine those programs to write this program. Because here you see I did string compare. I also did string copy. Therefore, those two programs are used in this concept. And therefore, already done how to allocate memory. Therefore, you know that you just take that code snippets and just try to paste over there. Write a small code and try to run it. Once you can run it, you will be feeling that you can write a code of this size and then you can gradually decrease. Normally, programming takes at least 2 to 3 months to develop. If you are new to it, it will take at least 2 to 3 months. Because some of the codes which I write may not be clear to all of you, but don't worry. You have to start doing over there. As and when the time will come, you will be able to learn the coding. Therefore, the next class, I will try to show you how to run with pointers to the functions. Normally, till now, you know that we can point a pointer to variables. But right now, in the next class, I will show you how you can use the pointers to a function. That way, function can also be pointed with a pointer. And that pointer is called a pointer to a function. Therefore, we have some advanced implementation. Since you all are learning data structures, we do not have a programming separate, but just to make sure that you should be able to know how to convert these programs convert these algorithms into programs, you should be conversant with that. Now, this class will not have any C programming. Will not have any C programming. Therefore, we'll write the algorithm, but the corresponding lab part you'll be having, in that lab you have to convert this algorithm into programs. Student of CBCS may not require to do the labs, but if you are interested to do the labs, we'll be happy to provide you that facility also. That apart from your syllabus, you can write at least 10-15 programs to make sure that these data structure programs can be converted into algorithm can be converted into the programs. I'll be writing all the programs and uploading it onto your classroom. Though I will not be discussing in the class, I will just show you the algorithm, and you can write the programs and convert into and you can check it yourself. But I will be writing all the programs. Say after teaching one topic, I will be uploading the programs on the classroom. Just you will be able to follow that. Therefore, don't worry. This is little tricky course because lot of algorithms are there. Lot of new algorithm can be developed. Now the books might contain hundreds of algorithms, but there might be other 100 algorithms which is not covered in the book, but which can be developed. Therefore, at the end of this course, I will be doing at least 5 to 7 classes, where I will be taking at least 30-40 questions which has come in the last GATE examinations, which will give you confidence that those questions can also be attempted by you. Okay. Therefore, I will gradually pace this thing. Therefore, a lot of time is there. The course will run up to maybe November end. That means you have already 4 months time. Therefore, there is no problem. We have full September, October, November, and this month also. Therefore, the course will at least have no less than 40 to 50 classes, at least 50 classes. Therefore, obviously, I will upload in this week the schedule of those classes also, so that you will be able to know what things I am going to do. Now, this is the code for. I told you that selection sort, bubble sort are not good sorting algorithms, but at the starting level, we want you to work in that. Maybe in the syllabus we are having heap sort also, we are having quick sort also, we'll be having radix sort, and all those sorts are there, which are more efficient than this. But starting, we try to use for selection, bubble, are the simpler sorts. Insertion sorts are also the same, except that you might be knowing that when you are going to play card game, you basically perform in insertion sort. Suppose you pick a card and you get 10, you put it like this. Once you pick another card, you get 8, you put it before 9. Then you get a card 2, you put it before 8. Now, once you are doing this, you are creating a space for that. Now, what you do when you are creating a space? Now, in that case, when I am performing an insertion sort, how it actually works. Now, these are the easier codes which you can know. I just show you how these codes are easy. Now, when I take an insertion sort, it's a very easy algorithm. Now, suppose I have an array like this. Now, suppose I get a number, say 12. I put it over there. Next time, I get a number 4. So what I do is that I have to put 4 before 12. Then what I do, I just copy it, I shift it over here and put 4 over there. Now suppose I get a number, say 2. What I do is that I again shift over it. I shift here, I shift it over here, and I put 2 over there. Now suppose I get a number, say 5. I have to put here. Then what I do, I shift this here and put 5 over here. Therefore, this is a insertion sort. But what happens in the worst case? You have to shift n-1 times the first. Therefore, now let us take how this algorithm works. Now, suppose the numbers which are coming, suppose if I say the numbers are, say 10, 8, 7, 5, 4, and 1. What the other numbers? So what happens is that you are going to write like this. Now in the initial case, it will have a number, you are putting 10. Don't require any shifting. Then you take the second number 8, you put it over there, you require 1 shifting. Then you get 7, you put it over here, you require 2 shiftings. Then you get 5, you put it over here, then you put it over here, then you put it over here, and then you put 5, you require 3 shiftings. Similarly, when you get 4, you put it over here, then you are going to put like this, then again you put here 7, then you put here 5, and you put 4 over this place. When you get 1, that means you require 4 shiftings, then you are going to put it over there, therefore you are putting this 1, then you are putting this say 10, here you put 7, then here you put 5, here you put 4, and then here you put 1. That means you require 5 shiftings. Now there are 6 numbers were there. In the worst case, you require 5 plus 4 plus 3 plus 2 plus 1. That is, you require this n square. That means you require how many times? 15 times, which is nothing but n square for the worst case. If you insertion sort in that, once you are going to do this, you are inserting like this. Now these are basically easier codes because you have to just make sure that the space is there and you just keep on shifting like this. Now this is the you can perform insertion like this. I mean you have to make sure that I have a space. This is how you are using a card. Once you are putting a card, you want to put a smaller card before this. You just shift the card like this and put the new card over there. If you get a bigger card, you try to find the place for this and put that card over there. And this is the way how actually sorting works. Now, when you are going to do this, you have to compare. Now, here the comparison is also there. Once you are going to compare the elements, you have to find the appropriate place for this. Now let us take example. If the numbers would have been, say, if the numbers would have been, say, the numbers would have been, say, 10, 8, 15, and say 20. We will put like this. First, you will put 10 over here. Then in the next case, you will shift 10 over here and put 8 over here. Then 15. How will you know where is 15? Therefore, you have to compare with this. Then again, you have to compare with this. Then you find bigger than this. Then only you can put 15 over here. Once you put 15, you have to compare whether the first is bigger than 15 or 10, because you have to find the appropriate place for 15. Similarly, when 20 will come, you first compare with this, then you compare with this, then you compare with this, and then you find that 20 has to come here. Therefore, the comparison is always there. It might not look. Even if I get the numbers in ascending order, suppose if the numbers are, say, 1, 2, 3, 4, 5, then also it will be something like this. You put 1 over here. Then to put 2, you have to see whether I should put before 1 or after 1. Therefore, you know that I have to compare with this. Then I put 2 over here. Again, 3 comes. I again compare with 1 and compare with 2. Then I find that 3 should come here. Therefore, every time you perform comparisons, and there is no savings as far as comparisons are concerned. And therefore, this saving, there is no saving for this. And therefore, ultimately, the number of comparisons are same. Therefore, when I talk about this, it is not shifting only, it's a comparison also. The first case you compare 1, 2, 3, and so on. And therefore, these are all algorithms in order of n square. Therefore, insertion sort, bubble sort, selection sort are all algorithms of order of n square. These are all order of n square algorithms. And there are simpler algorithms because you just require to play with the spaces of the array. Okay. Now till this is fine. But some of the codes which I will do, like heap sort, then the code of quick sort, these are little different because that involves some recursion algorithms are there, and some works on the different paradigm. Therefore, we'll discuss those paradigms also. What are different paradigms on which we can write the algorithms? There are a few of them. Divide and conquer is there, dynamic programming is there, then the backtracking is there. Therefore, there are 4 or 5 paradigms on which we'll try to show you that how this works. Okay. Now, any questions? And I will upload this slide today. Yeah, anything you need to ask? Now, from tomorrow, I will not be doing this programming. I'll shift to the other part of the syllabus because I will keep on writing the programs. But one class I will take for advanced concepts of how to write a pointer functions, and then how to convert the file, how to convert the C files to H files. But that I will do once you write few programs and you can do it yourself. Otherwise, that will take hardly 10 minutes for me to explain those concepts. Now, till now, you should be familiar with at least writing 2-3 programs so that you will be able to write a program how to make our own link files and header files. Okay. Now, anything you want to ask me, you can ask. I'm just taking attendance over here. Now 72 of you are present right now. If I am taking the attendance for each one of you. Okay, now fine. Taking the attendance. Therefore, you can disconnect. Otherwise, want to ask something, you are free to ask.